Alright, welcome back to part 6 of my algorithms video tutorial series. In this one, we're gonna, now that we know how to write to a CSV file, we're gonna write our first analysis of our very first algorithm. So we've already written the getRandomList utility function that will return us a shuffled list of a certain size, and we've already written the linear search algorithm that takes in any list and finds a value inside that list. Now we're going to put that into practice. We're going to generate, we're going to analyze the algorithm. We're going to generate a CSV from the results of that. First up, we'll want to import these into the main program. So I'm going to actually use the from utilities import, and then we're going to use the getRandomList. And we're also going to import the other one, which was linear search. So we can do linear search. With those two things loaded in, we should now be able to use them inside of our main program. So let's have a little think about what we want to do. So we want to keep the it's okay to open up the file, and it's okay to create the writer. The right of the first row we should probably change, because we want to make sure that we are writing what we're going to be measuring. So what do I actually want to measure? Well, what I want to do basically is I want to create a random list of a small size, maybe starting at 1. And then I want to do the linear search on that list, and it'll return the value of how many comparisons it took. So I want to store that value as the right-hand side one. So this should be something like size. So this will be the size of the actual data, and then the second value will be the number of comparisons. So comparisons. So this is the two things that I would like to measure, and all I need to do is kind of change this inner loop to kind of do that, and to write the correct values in there. So this range statement, what I think I'll do is I'm going to test it with some small values. So maybe I could start at 10, and I could end at, let's end at 30. It's only doing this 20 times just in case we get it wrong. I can change these values when I want to generate more. I don't want to start too low as well, because it's a bit pointless to try and find values in a list that's not any size at all. In fact, we could do just one, start at 1 and end at 20. That'll be fine. What we need to do is we need to generate a random list of size I, and then we want to search for a random item in the list, and then we want to write the values to the CSV, and then this will just loop around for each of the values from 1 all the way to 19. So let's, if you want to stop the video right now and see if you can apply what you've learned in the previous ones, to see if you can actually use your utility functions to do this. And then if you want to just watch me do it, I'll be doing it as well. So you can pause and try it, or you can continue watching. All right, so I'm just going to create a new variable, myList, and I'm going to use my getRandomList. I'm going to pass in I as the size, so this should get me a list of this particular size, this random list. I'm going to say the value that I'm looking for will be, and I need to import this import random as well, because I want to use random to choose the value that I'd like to select from this. And because I know that the list of size I will be a maximum of I, the value will be a maximum of I, then I can say that choice is random.randint. Now this is a way to get a random integer between a minimum and a maximum value, including both endpoints. So we're going to say from 0 to I, and that way we should be able to get a value that doesn't go any higher. It should be inside. Obviously, the other option is we could do random.choice and then use a choice from my list. And I think either way will work. You're welcome to give any one of those a go. And then we're going to do our actual search inside of that. So we're just going to say, because we know it returns a result, it turns the number of comparisons. So say result equals, and we'll do linear search. The values we pass to linear search is the list. So it's called my list. And then the value we're looking for is the one we calculated, called choice. So the two things we're going to write into this row is the size of the list and the number of comparisons that it took, which we have in result. So I is correct. We are going to write I in there because that's the iterator inside the loop. And the result is what's going to be written into the other one. Let's test this and see if it works. So quickly testing it, the test.csv gets generated real quick, and everything works as you'd expect. So with small values, you're getting, this is an exact sort of like in the middle value. This one's all the way at the end. This one's pretty close to the start, So let's just have a little look to see what that looks like as a CSV file. So I just downloaded the CSV, opened up inside of Excel and shown a line graph. So you can see with this small number of samples that it's a little bit random. It's a little bit all over the place. But you can kind of, if you have more data points, you'll be able to see an approximate average. So if you were to draw a line between them, you'd see this approximate linear increase in the efficiency of this algorithm to find the thing that it's looking for inside of that random list. And you should definitely, I'm going to close this and not save, so you should definitely change your code slightly. It took only a millisecond or two to run through 20 samples, but you can go up in any number that you want. You can go up to any value that you want within the time limitations that you have. Remember that the range statement as well, if you look this up, you can actually go up in different numbers. You don't have to go up in one. You can actually choose a third number. So an example I'm showing here would start at 1, it would end at 200, and it would go up in steps of 10. So it would do 1, and then it would do 11, and then it would do 21, and then it would do 31, and it would keep going until it was up to before the 200 mark. So feel free to play around with those numbers, and feel free to try and generate a more complex graph for your analysis of the linear search algorithm.